Hello, this is Dan Alford. Welcome to the ARC Specialties Weld of the Week. So in a materials testing lab, not only do we do destructive testing, but we do a great deal of non-destructive testing. We've got Jason here today. He's going to demonstrate 3 different technologies. What's our first one?
Dan, our first one is wet fluorescent magnetic particle inspection.
What's this used for?
It is to detect surface indications that can't be seen with the naked eye.
Cracks, porosity, what can
Cracks,
you find with this?
Lack of fusion. In this case, there's a little bit of lack of penetration. Pretty much anything, rounded indications are hard to see with magnetic particle inspection.
Is this one visible or is this fluorescent?
This is wet fluorescent. It is a prepared bath. It is fluorescent bombarded iron particles that can only be seen with an ultraviolet light.
And how do you magnetize the part?
What we have here is a yoke. It's called an AC yoke. It does not magnify until we energize the yoke itself.
How's it work?
Well, what you do is the first thing you want to do is clean your part thoroughly. Wire brush, make sure you have no spatter, anything like that on the material. And then if you're looking for transverse cracks, the yoke makes a longitudinal field. So it's going to run from north to south or south to north, however it leaves the North Pole and it enters to the South Pole. So you've got a longitudinal between leg to leg indication. So if you're looking for a weld that is indication that is parallel to the weld, you would want to go 90 degrees parallel to the weld, as like this.
So you have to rotate it once to get full inspection?
Yes, you've got to do 90 degrees here, perpendicular to the weld, and then you're going to go 90 degrees parallel to the weld to get your parallel indications or your transverse indications.
So once the part's magnetized, what's step 2?
You go ahead and energize your part, and then you add your prepared bath, 14 AM, your fluorescent bombarded iron particles, and then you apply it to the part, and you let all your excess drain as much as possible. And as you're still energized, you would introduce a ultraviolet black light.
So what do you got? You got a good part?
No, it's not.
So I see a crack on the center line. What is that? A crater crack?
It's a crater crack. It's probably due to the lack of fusion. The lack of fusion created a stress riser and created the crater crack.
So is this a process you use in the field?
Yes, very, very versatile in the field. We've got battery packs that we can run our yokes in the field with no electronic at all, just off of batteries.
So when do you use this and when do you not use mag particle?
Well, the fluorescent you can't use during the day. It's got to be in a darkened area.
Gotcha.
Wind, rain it's a factor on the downside of it. But other than that, if you can get a pretty clean, darkened area, wet fluorescent is my choice.
And that's better than the visible?
Yes. Yep.
And so this won't work on any material that's non-magnetic. So this won't work stainless, aluminum?
Copper, nothing, no.
So it's strictly a steel application?
Yes. Carbon, high carbon applications. It can be used in 304, but it's you wouldn't get the same exact results. Clean, crisp results like this.
Another non-destructive testing technique we use is ultrasonics. One of the advantages of ultrasonics, you can find subsurface indications. Jason's going to demonstrate this technology to us. What kind of sample you got here?
I've got a sample here that is a 8-inch pipe that has lack of fusion and lack of penetration at the root.
And so this technology will be used to inspect the inside of the pipe from the outsides.
Yes. This is where you use ultrasonic shear wave, just like you said, to look at materials within the walls of the weld and the pipe itself.
Show us how it's done.
Okay. This area right here, we're known as it's a good weld. This right here is what you call a root roll. You're actually getting good penetration into your root.
You get the knuckles down a little bit.
And as we go a little further towards to my left, you can actually see the lack of penetration starting to come in there. And it runs the whole from this area all the way down to this area right there. I'm losing a little bit of cup up there, right there. Still a lack of penetration there. And then we also have a root crack here.
So is this technique used in the field, strictly in the lab, or where are we going with this?
Yes, I mean it's very versatile in the field. Everything's battery operated. Very good for field, and you can also use it in a lab setting as well.
So what are the percentage of the field inspections you're doing with UT? Is this your primary tool?
Mainly to do, flaw detection, yes. We usually do ultrasound. Unless they do have something that's open to the surface, we'll go back to our magnetic particle inspection. But yeah, this is anything that we're looking for subsurface that they don't know that's there. That's what we're looking for.
And so this process isn't limited to steel. This will run other materials?
Yes, I mean you can do carbon steel, stainless steel. But when you get into the stainless steels, it's a little harder. You have to have an actual calibration block that you know that you're going through the weld. Because, when you do a stainless steel weld, it's like taking bowling balls, is the way I like to put it. You're stacking bowling balls. And what happens is when your sound hits that weld, it attenuates it so much that you lose so much sound on the second half of the weld.
That's all part of the calibration process.
Yes.
So you've already calibrated this
Yes.
unit before we
Yes.
started today?
This is calibrated, yes.
So does this replace radiography as an alternative? Or when do you X-ray, when do you UT? What's the thought process?
Well, the UT is used, you can use UT in X-ray or in lieu of X-ray, or you can use X-ray in lieu of UT. If your customer is wanting a permanent picture of the indication that you're seeing, X-ray is the way to do it. If you're in a limited area where you cannot have X-ray, this is your test method.
Because if you can't put it in a bunker, you have to evacuate the building before
Yes.
you do radiography.
Yes, sir.
I'm going to demonstrate another non-destructive testing technique that's used for surface indications only. What are you going to show us here?
I'm going to show you, it's called red dye penetrant inspection.
So this only works for surface defects, right?
Yes,
But does it work for non-ferrous materials?
it works for ferrous and non-ferrous materials. You can use it on both.
Okay. In my understanding, it's one of the most conclusive techniques for a surface defect. Would
Yes,
you
it
agree
is.
with that?
Yes,
So you can find very small cracks, small defects,
yes, and it's very versatile.
and it's inexpensive.
Very inexpensive.
Only takes 3 spray cans.
Yes.
What's the first one?
The first can we use here is called SKCS. It is an aerosol solvent that we use to clean the surface, and we also use it on our second step to remove the penetrant.
How's it work?
Okay. First, we're going to clean a little area here. Spray your cleaner on. You wipe it down and make sure you get the toe of the weld good and clean. Make sure there's no slag or anything like that on the weld. And now we have to set for 10 minutes and let that evaporate completely before we can add our penetrant. Okay, now we've waited 10 minutes after our cleaner has evaporated. We give it one more dry wipe just to make sure. And then we add our SKL SP2 red dye penetrant to the surface area that we've already cleaned.
So that penetrant's actually soaking into the defects?
Yes, it will. The viscosity of the penetrant really dictates the length of your dwell time.
And how long are we waiting on this one?
This particular test here, we're going to wait 10 minutes according to our procedure.
And what are we looking for here? Cracks?
We are looking for lack of fusion at the toe. We are looking for any linear indication that should not be in the surface of this weld area.
So we have a dwell period of 10 minutes?
10-minute dwell time. We can also, instead of spraying this, we can also brush this on. Brushing is a little cleaner, a little neater. We don't get as much run, but for this application, we just sprayed it on.
And there's a fluorescent version of this technique.
Yes, there
too.
is. Same concept, but you're going to have to be in a darkened area, and then you're going to have a black light. That's why the red dye is so versatile. Anywhere, day, night, you can use this.
So we'll come back in 10 minutes and do the final inspection.
Yes, sir. Okay, we've had our 10-minute dwell here. What I like to do is take a dry rag, no solvent, and wipe up all the red excess as much as possible. A little pink hue there, not a problem. Once I get all the excess off, I'd like to take a little bit of cleaner, spray it on my rag, dampen the rag a little bit, and then give it another couple wipes, 1 or 2 wipes. Once you realize you've got, a little pink hue on your rag, you're clean enough. So now we've got another 10-minute evaporation time for the cleaner. All right, our 10-minute evaporation time for our post-clean after the dwell time of the penetrant. We use some SKD S2 developer. What this does is gives a contrast for the red to stand out so we can see with our eye. We apply this, you want to go out 1 inch from the toe of the weld to the heat affected zone on both sides of the weld, cover the whole area that you have put penetrant on. And then we have another 10-minute dwell with the developer as well before we can make any calls on any indications that are shown in this weld. All right, now we've waited 10 minutes, our minimum for the dwell for the developer, before we make any calls on any indications that so happen to come up in this weld. This area here, we got a little bit of a red hue. That's probably maybe just a little bit of poor cleaning on my part, but I would still go further with the inspection due to, I have no serious red bleed out, just a little bit of a pink hue. Other than that here, I look here and I don't see anything that's sticking out in my mind or my eyes that would cause me to reject this weld. This weld right here, as of right now, is a good weld.
So Jason, thanks for demonstrating these 3 non-destructive testing techniques and showing us the strengths and weaknesses of each one.
No problem. Thank you.
If you need assistance with welding procedure qualification, contact Matt Brinkman at Welding Consultants, LLC in Columbus, Ohio. We look forward to posting new episodes of the ARC Specialties Weld of the Week. If you're one of the thousands of operators of ARC Specialties equipment around the world and you have a weld that you would like to showcase, please contact us. At ARC Specialties, we thrive on problems. Send us yours.